In problem 4, we're going to build a confidence interval for the difference in two proportions. Your confidence interval is going to determine whether there's a difference between male and female support for the president. The sample proportion for male support of the president is found by dividing 238 by 553. The sample proportion of female support for the president is found by taking the ratio of these two numbers. And I've copied these numbers already into Excel. The president's male support is found by taking the number of people in the male sample, 238, and dividing that by the size of the male sample, 553. The size of the male sample is 553. To calculate the president's support amongst women, we take the number of women in the sample, 212, who support the president, and divide that by the size of the female sample. The size of the female sample is 569. The variance that we're going to use for the male proportion is the male sample proportion times 1 minus the proportion of males who support the president. The cool thing with Excel is that by clicking on the bottom right-hand corner of this cell, I can repeat this calculation very quickly for the variance that we're going to use for the female support for the president. If I click on the cell E4, the sample proportion for female support of the president times 1 minus the sample proportion of female support for the president. The point estimate of the difference between the population proportions is just the male proportion minus the female proportion. Because the confidence interval does not state anything regarding whether these proportions are expected to be equal, expected to be different, we don't pool the proportions when calculating the standard error of the difference in sample proportions. And from this point on, this particular problem is identical in the following steps that we would take in a two-mean test where the population variances are known. So the variance of the difference in sample proportions is equal to the sigma squared for the males divided by the sample size plus that of females. The standard error is just the square root of what we just calculated. Now I'm going to copy the standard error from this spreadsheet into Cengage Now to 6 decimal places. Now in part C, the sample proportions are not pooled because in a confidence interval, the proportions may or may not be equal. The answer that's supposed to go into part B, the point estimate of the difference between population proportions, has to be to 5 decimal places. And this is to 5 decimal places. So we're going to copy that back into Cengage Now. The critical values for a 99% confidence interval, there's 2 of them, plus or minus. I'm going to copy this 99% into Excel, and then from there we're going to get the significance level We're going to divide the significance by 2 and then find the critical values. Now, since the confidence level is 99%, alpha is 1%, we are dividing the alpha by 2 because there is an upper limit and a lower limit to every confidence interval. So here we're dividing the alpha by 2. So alpha divided by 2 is 0.005. And we're going to find this critical value in the standard normal table in column 0.05 and the infinity row, because in the infinity row, values in that row are standard normal or z values. So in column 0.005, we go all the way to the infinity row, and we see that the critical value is 2.576. And there's 2 of them again because there's a positive one and a negative one. The confidence interval is equal to the point estimate of the difference minus the margin of error. The margin of error is equal to the z-value times the standard error. The problem in Cengage now is asking for confidence intervals to 1 decimal in percentages. So I'm going to change this to a percent and then add a decimal place. The upper limit of the confidence interval is the point estimate of the difference plus the margin of error. The margin of error is the z-value times the standard error of the difference. Again, we want to convert this to a percent and then add 1 decimal place. So the confidence interval has a negative value and a positive value. Thus, we are 99% confident that the difference in proportions is in between a negative value and a positive value, suggesting that there is no difference. I'm going to copy these values back into Cengage now so that we can complete the problem there. The critical value to 3 decimal places is 2.576. The lower limit of the confidence interval, negative 1.7%. Now, I don't include the percent sign because the percent sign is outside of the answer blank. The upper limit of the confidence interval is 13.3%. And again, I'm going to get rid of the percent symbol because the percent symbol is outside of the answer blank. The confidence interval above implies that males and females support the present equally. Confidence level 99% is the percent of confidence intervals that are expected to contain the difference in population proportions. I'm going to check my work and we should get everything correct. And we do.